My name is Mario Sabrino. I'm one of the 7 seniors in CS 334, System Design and Implementation. This course is the Capstone experience in the computer science major. And throughout the semester, we work as a group on a single project. We apply ideas that we've developed throughout the major, and we are introduced to new technologies and concepts. This semester's the academic content for the course came from various series Clean Code. So this is Robert C. Martin, also known as Uncle Bob, first wrote the book Clean Code in 2008 and then produced a video series in 2016. We watched a number of the videos, and some of them were a bit silly, but they challenged us to think about the things that we do as developers that hurt a project. For example, long methods where you can't really know what's going on or what it's trying to do. Bad names, which can cause confusion or could even be misleading. Complex architecture could be difficult to bug and understand what's going on. These types of bad decisions add up and affect productivity over time. So this is a graph from the Clean Code book that illustrates the concept. So here we start off with a fast transition in productivity. Over time, though, as we make up these bad decisions, we start to see our productivity go down because we end up wasting time on either having to refactor or debug all the mistakes that goes along with it. So our goal this semester was to try to avoid this type of slowdown by utilizing techniques described in the book, as well as industry best practices. For example, we held ourselves to apply a pure test-driven development approach, and we tried to achieve 100% code coverage. We studied the concept presented in Clean Code and applied those ideas in our code. To help, we used Python to automate checking for coding standards. And we used the Jenkins continuous integration service to automatically verify all incoming pull requests. We believe that these techniques helped us to successfully complete our project.
So, earlier this semester, Dr. Coleman introduced us to Tangsosa's inventory beer data. This data set contains information on Tangsosa's current beer inventory. So this includes stuff as beer names, size, price, and so on. It's a powerful data set, but it doesn't have much information about the styles of the beers. So we joined this data set with BreweryDB. And BreweryDB has much more information about the types and styles of beers. So what we did is we wanted to create a simple SMS app to demonstrate a way to query the joined information. So for example, you can send a text message saying IPA, and then getting results saying there are 7 beers with the style. Of course, it's probably going to be much more than that, but that's the idea we wanted to go with. So we created a system that scrapes from Tangsosa's, which is our data collector, and that stores that information into our database. The inventory API is a RESTful API that points to the data storage and allows this data set to be queryable. The Twilio API is a system that allows users to interact with the inventory API, and ngrok is an application that exposes local servers to the public over secure tunnels. We use it for our Twilio so that way we can get through our Moravian firewall. So all these are microservices, respectfully. So microservice being the data collector, the database, inventory, and so on. So to keep all these microservices separate from each other, we implemented them in Docker containers. So we're going to go through each one of these microservices one at a time, starting with the data collector.
So the data collector microservice is designed to solve a simple problem. Tangsos makes new data available to us every 15 minutes. We have our data collector set up to make requests and fetch that data every 20. We then store it in the directory where we want our files to be. The app runs pretty much continuously. The most interesting feature about it, though, is it's headless. And so in order to understand whether our requests are succeeding or failing, we've added logging functionality. Successful requests are logged as our failures, and we're able to examine that if there's a problem to see what's happening. This is a pretty simple flow of data. It's a simple microservice. Our next one, the inventory API, is going to be a little bit more complicated.
So the inventory API microservice allows the user to query our system using REST API. It's comprised of the Flask server, the business objects, and the data. we're going to start by exploring the Flash server. So our Flash server is an application that pulls data from our system according to the user's specifications. There's a wide variety of questions that the user could ask about the data, and it's only using one input. For example, if you wanted to, you could ask about 6 packs of stouts. You could even ask about kegs in any size of Guinness. Even if you just wanted to ask about anything Guinness, you have that ability. The result of those queries are going to be returned to JSON and all the necessary information about the beer, such as size, style, quantity, and price are going to be present. So the way it works is the Flash server passes the user's desired criteria into the business object, and we wanted to have the delivery mechanism interchangeable for the rest of the system, and so to enforce that boundary, we decided to make the business object responsible for processing the user's input. The decision to have that separation between Flash server and business object allows us to swap out the Flash server for a GUI at some point. This provides the opportunity for future work, and it also makes the boundary between business object and delivery mechanism much more concrete, and it ultimately goes along with Robert Martin's ideas on clean code. But in order to fully grasp what the system is doing, we need to go more in depth with what the business object is doing.
The primary purpose of the business object is to make queries of inventories of beers. So in order to keep the separation here, keep the boundary between the business object and the delivery mechanism, parameters for queries are passed in the form of a data structure and passed through to our filter factory where we can create actual filter objects. The most interesting part of this process is the actual creation of that filter object, which we implemented using the decorator pattern. We wanted to be able to use 4 different types of filters: name filter, availability, size, and style. The name filter, pretty straightforward. It filters by beer names. Size filter filters by container size. Style, self-explanatory, filtered by beer styles. The availability filter is a little bit of a misnomer we realized late in the project. We didn't have time to refactor that, but what it actually is doing is it will tell you whether a given number of beers is available in Tanzo's current inventory. So you'll see for each of these, if you look at style filter, for example, you can see it has an abstract filter object. This object can be, this filter can be a size filter, or an availability filter, or a name, or a yes filter. I'll get to that one in a moment. Say in the same way, the name filter has a filter, which can be any of these other filters. The yes filter here is our base filter, which always returns true. This allows us to build up a filter object where each layer has a filter, which in turn has a filter, turning it into a recursive structure. It might be easier to understand with an example. So in this filter object, we initially query with a beer name. Assuming that that name is in our inventory, we query those results for a beer size. And if that size of that name is available in our inventory, or is in our inventory, it goes to the base filter, which returns true recursively all the way back out, and we get our filtered data. The nice thing about having this system in place is that other than the base filter, this allows the user to use any number and any order of filters to create different types of queries. So, for example, if I wanted to check and see if there are currently 2 half kegs of my favorite sour beer in stock currently at Tanzo's, I would create a filter object with the name filter on the outermost layer. The name filter has a size filter, has an availability filter, has a yes filter. If I wanted to ask about which loggers Tanzos carries in a 24 pack and create a filter object, which the outermost layer is a style filter, which has a size filter, which has a yes filter. If I wanted to do a more general query and just ask about what all currently available beers, everything they have in stock at the moment, I'd just create a filter object that queries for availability. These filter objects allow us to query for any kind of information.
So as Steve was talking about the beer data and the filtering, it's actually much more than that. In the data file, this is a simple screenshot, but in the data file there are approximately 8,300 entries. We can see that there is a price associated with each item, a quantity, a category, which Tanzos associate each item with, a size, and a beer name. Roughly 65% of the entries have a zero quantity, which means that they're not in stock. Also, you can see the entries, there are duplicates, Guinness and Guinness, however, they have different sizes. Another issue that we came across was category. There was only 7 categories in the Tanzos inventory. That wasn't enough for us. So in order to apply these systems, these styles to our inventory, we needed an external service. BreweryDB is a database of breweries, beers, and beer events, where we use it to look up the name and attach the style into our system. This API has a ton of endpoints here that we don't use because it's more powerful than we need. If we were to query for Goosinator, this is the endpoint that we would use, and this is the result that we would get back. The search endpoint is also more powerful than we need to use it. We simply use it for the style name and the short name, which is a simple substring. When Steve was talking about the inventory, it was actually made up of 2 different entries. We're able to abstract our inventory, the Tanzos inventory, into BreweryDB queries. So our current inventory acts as a join between Tanzos and BreweryDB. The business objects return the data without exposing the internal details of the process. This allows us to provide data that unknowingly uses the BreweryDB capability. Each of these databases had challenges of their own, but we first will introduce how we store Tanzos data file.
On the Tanzos side, the main challenge we had was how to design our application in such a way that its functioning was independent of the way in which we stored the data. Our solution was we built our application so you had to access the data through an interface. Currently, our data is CSV files stored in a directory. Most recent file is the class that has this interface. It'll return an iterator to current inventory, which then can iterate over the data without any idea of how the data is actually being stored. This is useful because in the future, we've talked about subbing out our directory with CSV files to a more complex database. And if we did that, database access would have that interface. Instead of searching over a group of files in a directory, we would use SQL or some other language, but current inventory would not need to change anything. It would still be the same idea of an iterator being returned to it, where it could call the next method on and get that data. This idea of having breaks between parts of our program that changed is something that you've seen before. Flask also had a break between the rest of the project and itself, as database access would in this future. And that's something that we think is crucial. Either of these could be subbed out and the rest of the functioning would still work. There is one thing of data though that is not separated like that, and that is the BreweryDB.
So, as Adam said earlier, style information doesn't come from Tanzos. So we had to create a style DB to house both our beer and style data. However, there's a bit of a challenge to that. So Tanzos has 8,000 beers in one file. However, BreweryDB only allows 400 requests per day for us to call it. So therefore, we had to create a style cache to hold some of that data in memory, so it can only query out for DB to BreweryDB for the styles we haven't seen yet. So we did this earlier by by building up our cache over the past couple days. So now that's set though, we still need BreweryDB though, because let's say if we get another file and there's more beers in that file where those beers aren't known to our cache. So we still have to make those requests and have that functionality. Therefore, we have the style database object that will coordinate the efforts between the two modules. So that was kind of a lot. Let's step back a bit and see what we have here. So we create a RESTful API with a Flask. The Flask app, that's a boundary between the delivery mechanism in the green here and the backend that's in the orange. The red represents a generic implementation of the queries against our beer data. And then all the way to the right-hand side, that's where we abstract away our data sets. So in the blue there, that's our TankSource data, and then light blue is our BreweryDB data. So this was the second of our microservices that we use. The third service allows users to query the data is using Twilio.
Twilio is a cloud communication platform that allows software developers to programmatically make and receive phone calls and send and receive text messages through their web service API. For our project, we incorporated the text messaging services of Twilio. So a user sends a beer style to our Twilio number. Twilio then makes a post HTTP call to our Twilio Flask, which makes a GET request call to our beer API, which returns to us a list of beers in JSON format. Our Twilio Flask will then process the data, sending the response back to Twilio and sending that as a text message to the user as the number of beers with that style specified. Conceptually, this is how everything should work if our Flask server has direct access to our internet. But this line causes a problem because it represents an incoming call through Moravian's firewall. The way we got through this is we used something called ngrok. Ngrok is a multi-platform tunneling software that establishes a secure public endpoint to a local running network service. So instead of having Twilio have direct access to our Twilio Flask, it'll now make a post HTTP call to our ngrok, and then ngrok will make that call directly to our Twilio Flask, allowing for a secure connection, allowing us to send and receive text messages successfully with even through Moravian's firewall. And that concludes our final microservice for our project. But now let's review everything. We have a data collector that collects data from TankSource inventory. We have an inventory API that makes our database queryable. We have a Twilio API that allows us to make queries to our inventory API. And we also have ngrok that allows us to have access even through Moravian's firewall. So now that we had a recap of everything, ladies and gentlemen, it's time for a demo. Let's see how this goes.
Make it ID to do this?
They're 21.
They're putting on here, I'm gonna give them an A right away.
Yeah, I'm good. All right, everyone, so this is what we're gonna do. We're gonna make 3 separate queries. One should return a style with a lot of beers, one should have just a couple, and then one should have none, because it'll be just a random word. All right, so the one that should have a lot is porter. And let's see it. Yeah, 197, that's what we were looking for. All right, brown ale should have just a couple. Yeah, right, 2, that's right. Let's see what the word below. Yeah, that's what we're looking for. So we're gonna let you all try now. And we're gonna put a number on the screen, and when you text, make sure the words have the first letter capitalized and no space, no trailing white spaces at the end.
So while you're texting, you'll notice that this follows our pipeline, where your text messages are coming in through our ngrok app, our ngrok service,
He doesn't know why.
going through Twilio, and all the way back out.
I'm sorry, wait.
Oh no!
Do that one again, John.
We'll do it again.
What a wine drinker back here.
I mean, there's needs.
There's also means, yeah.
Don't we need the first letter to be on the first word capitalized,
Yeah.
isn't it?
Yeah, that's,
Like
Yeah,
capitalized for
yeah,
the,
yeah.
it's like title case.
No, but it did get, oh, that's something to
No, there's
do
needs
with
there.
it.
Yeah, so over here, these are all of our services running. So start over here on the right-hand side. Up here is our beer API. As you can see, it's being updated right now by the queries. On the left-hand side over here at the bottom, that's our Twilio API. And then right over here is ngraph. So basically what you're seeing is, luckily, all 200 requests. So everything's working well. And one thing else I want to mention, up on the left-hand side here, this is our status and log from our data collector. So what you see here is that the data that you're querying right now is actually was just queried a couple minutes ago at 4:04. So the data that you're querying right now is the data we just pulled. So roughly the next 20-ish minutes, we'll see the next date. If someone accidentally goes to Tanzos and buys like all the quarters, you'll be able to see that within the next 20 minutes.
yeah, that's why it's asking.
I tried using emojis.
Trying to break our system.
Sorry.
The emoji are probably Unicode.
It didn't have an emoji beer,
Oh
but
yeah,
it didn't,
no, yeah,
it didn't die.
Is our style?
I think all the emojis are Unicode.
Put it.
I just put on. Is it,
You just made that R, that's awesome. Huh.
maybe it starts with a line.
Jen did just the capital letter R.
Like a vodka, something.
There are 117 beers of style R.
That's new.
Well,
I don't know, I don't want to go to Kansas. It's not really here.
Yeah, well, I was just wondering if it like searched for.
Does this actually go against available inventory, or is it all inventory?
It's available. It's available.
It's available.
But do you need the full name, like, I mean, does it do a, I'm so slow. Yeah, but like, does it take maybe the first letter, or like,
I think if it contains that,
right,
what you sent.
then it'll return that.
Oh, it's a
Yeah.
contain.
Yeah.
Oh.
That's-
Like an ale.
Yeah, it's
Except it starts with letter B, it will give you.
King's letter.
Oh,
That's what more.
That would be,
Oh, yeah. That's what you should be able to do. Changes.
is this all there or just like? Sorry, no results for that. Yeah.
And that's, oh. That spelling.
Okay, so now that we've gone through, shown the internals and shown the live demo, we can now go into the process that we use to develop the system. So in order to stress the idea of clean code and doing this right instead of fast, one of the more crucial aspects of our process was Scrum. Now, we only meet 3 days a week, and we have work to do on other projects, so the structure of Scrum doesn't fully fit into the academic setting. But one of the aspects of Scrum that we did heavily use was the stand-up meeting. During those stand-up meetings, we would discuss what we did since we last met, what we planned to do, and then what we were stuck on. Dr. Coleman would provide feedback as to how to resolve these blockers as a Scrum Master, and then also suggestions for the direction of the project as the product owner. We also used the task board to track who was working on what task. So our task board is pretty typical in terms of project backlogs. We have a backlog, current tasks, in progress, and then done columns. And this task board was never completely set in stone. Some issues weren't on here, and often more people were actually working on the tasks than were assigned to them on the board. Towards the beginning, when we weren't utilizing the task board as much, there were times where people were concurrently doing the same task and didn't even know it. For instance, when we started making code style consistent, people began making the same changes all at once, and we ended up having merge conflicts when pull requests were made. Once we started to ramp up usage of this board, the frequency of duplicated work like that diminished. We were able to utilize the project's feature on GitHub in order to create this board, and our use of GitHub doesn't end here.
So we utilize Git and GitHub as our version control for the project. In past classes, we were given assignments that we cloned, and once we completed the assignment, we pushed back. When we came to Capstone, we were introduced to more features and learned much more how powerful GitHub can actually be. And so we became proficient in using Git when we were introduced to the idea of skill tests. So a skill test is an evaluation of our ability to perform tasks fluidly. We practice using the new concepts that we learned in class and technologies until we can perform them proficiently. Once we were ready, we sat down with Dr. Coleman in his office and performed tasks right in front of him. So here we have an example of a skill test where we had to use git squash. So the idea of the skill test right here laid down is we had to rewrite the history of sequence commits using a squash command, changing them to one commit message, and keeping up any useful commit messages as is. So when I had to perform this, I went to Dr. Coleman's office. He had a Git repository. He had me clone a Git repository, which he had set up specifically for this type of test. And then so he had me then read the history of the Git, or he had me use Git history to check the history of the current, committed commits. And then from that, he had me squash down a bunch of random commits that he had created onto one or two messages. And we used a 5-point rating system in order to determine how well we did with the test. So with the skill test, I performed a perfect pass. So first attempt would be 5 out of 5. Our second attempt would be a 4 out of 5. Our third or more attempts would be a 3 out of 5. If we attempted but never passed, that would be 2 out of 5, and if we never attempted at all, that would be a 0 out of 5. So with the skill test, I can now understand that git squashed is used to sort of put all the commit messages into basically one or two commit messages, which is nice to keep the history clean. And so we would want to keep the history clean in order to say if there was a bug in an earlier build, sort of track that down without having to go through a whole bunch of commit messages. Using these skills came in handy in order to keep our workflow at a steady pace. And so we all know that when we create a project, we have our upstream created for us. We will fork our own repository. We then clone that repository into our own machine, which allows us to then be able to push up to our forks. And for us, a new concept was making these pull requests, because we haven't really utilized that ever before in class. Two interesting concepts here are, one is anytime there's an update with upstream, we can pull upstream down to our local repo to have the latest build and then push that up to our fork. This is so we are always kept up to date and make sure that the latest updates doesn't break what we're working on. Another interesting concept here is this sort of crisscross right here, where we're able to pull out of our other colleagues' repos as well. So this allowed us to collaborate with any sort of work. And so an example would be me and Jose worked on StyleDB. I worked on the implementation portion of it. He worked on tests and mocks. And then so we both have our separate machines here where he has his work, I have my work. Once I finished with the implementation, I pushed it up to my fork so Jose then can pull it down to his repo. And then with that, then he was able to test all the mocks and all his tests to make sure that the implementation worked as it does. When he was complete, he pushed it up to his fork then I can pull it down so I can make sure that it works with my build and my machine. Once we were ready and we were confident that the build works correctly, is ready to be pushed to upstream, one of us then created pull requests. And with pull requests too, there is a little bit of challenges as well. In the beginning of the semester, when we created a pull request, Dr. Coleman reviewed them for us and made any sort of comments of any changes or any maybe little tweaks that we should do. So an example here would be Marty here making an attribute and a method for one of our objects. So Dr. Coleman here asked him to update one of the texts for his one of his files, and so he made the change, and they communicated back and forth until the build was seen to be fit and ready for production. So then they merged it. And later in the semester, we were entrusted then with the task of dealing with pull requests. And there's a little bit of story behind this where in the beginning, we were sort of afraid to do these pull requests, only to the fact of we didn't want to merge a pull request that might break the build and be the one responsible. But after a little bit of time and a little bit of push, we did gain confidence. And this is an example of one of us doing a pull request. So here we have Andrew making the most recent file with its implementation of all its tests. Then here I just made a comment, just having add a comment in one of the files, so that way it's pilot compliant. And then so he made the change. I checked to make sure his code is all good. Everything seemed to be fine. So then I merged his pull request. One issue we had to address was that we're not perfect at reviewing code all the time. We were busy with other schoolwork and at times maybe from other activities when we'd be exhausted. And so we could have just skimmed over some code from a pull request and maybe there's some bugs that we missed. So to address this, that's when we integrated the Jenkins service into our pull request.
So, along with our Git process, we wanted to have an extra layer of safety for our development and production branches. So we implemented Jenkins continuous integration server. To see this in action, let's look at this pull request real quick. So Andrew just made a pull request, and as you can see here, the first commit fixes Twilio. There is a red X on the right-hand side. That is our Jenkins continuous integration server. It's complaining because something's not right, whether that be coverage or unit testing, which we can figure out. So then Andrew realizes that, he goes through, makes some changes, and then we have a green bar, that green check mark. Then Adam can go through, make some comments, some more commits, and then I went through it and merged it through. So really, Jenkins triggers whenever a pull request is created in the master branch. So what we have right now is that Jenkins, once the pull request is created, Jenkins checks out that pull request, runs unit testing, coverage, and style testing, and then will notify when the pull request is ready to be reviewed or whatever it needs to be fixed. So what we have here is our Jenkins dashboard. As you can see right here, this is the status of our pull requests. Currently there's two nice little suns here telling us that we're in good shape, while other ones still need to be worked on. And we get information from this as to when it was last successful, if it failed at all, and even how long it took. This is also very helpful when we're trying to figure out what went wrong with our testing and debugging, both in terms of our code and with Jenkins. And so to go down a level deeper, really when we run with our continuous integration server, we're running processes. So right here, right now we have a node, and this node makes up could make up one of the many processes that you want to run during a build. And basically within a node you have a bunch of stages. And then within a bunch of stages you can have executable lines to be ran. So as you can see right here, in the first stage we fetch, that's our pulling out a pull request. We do some unit testing for our second stage, and then we have a static analysis for our pilot. So when these run, for example in the unit testing or in the static analysis, if something goes wrong, this will break in there, thus letting us know in the pull request what happened. So the pulling down from GitHub and pilot might seem pretty self-explanatory, but there's one other thing that we had to add in here for our unit testing, and that is called tox.
So before I get into talks, I actually want to cover virtual environments. So in this scenario, we have two applications running, App 1 and App 2 with one dependencies file. App 1 wants to only import the foo library, and App 2 wants to only import the bar library. App 1 also wants to use a different version of PyTest, but in this dependencies file, there's only 3.4.1. Also, so this issue can be solved by using virtual environments. So in this virtual environment, App 1 is able to only use its library foo and its desired version of PyTest 3.5. App 2 can also use its library bar and its version of PyTest 3.4.1. So each project can have its own dependencies regardless of what other projects want. The goal of virtual environments is to customize and isolate environments in order to create an applicable service on any computer. So any clean computer has to run the same build process in order to implement our system. The first line creates our virtual environment. Second line here activates it. The third line installs our dependencies, and the last line implements our system. But instead of doing all these steps, Tox automates the build process. Tox is a generic virtual environment management system. It helps standardize testing in Python and allows automatic customizable virtual environments. Tox manages to build everything from the command line. So when we run Tox, we can see that it instantiates our ABV, imports some of our requirements. We can see Pylint, Twilio, PyTest coverage, and so forth. We can also customize Tox to board Python 3.5, Python 3.6. You can see all the tests pass as well. Tox does everything automatically. Tox can provide us a way to configure our unit testing within each environment.
So for unit tests, we were trying to stay guided by Uncle Bob's 3 principles of test-driven development. And they had a specific meaning for us in terms of how we approach things. What the first rule really meant is that you always write your tests first. You should have a failing test before you start writing production code. For the second rule, the basic idea is that you should be testing in small increments. A test should be testing for just a little more functionality than the application currently has. And then for the third law, the idea is that all your production code should be focused on making that most recent failing test pass. Nothing more and nothing less. Now, these are just general laws, but we had a specific sequence of actions we wanted to take, incorporating those into how the application was developed. First, we would start out with a failing test that corresponds to red. Then, our efforts there are focused on making the test pass and getting to green. This is a lot of what you saw on the last slide. What's really added here is this idea of refactoring. The idea we wanted to make our code essentially clean as opposed to just functional. So even if code was passing a test, if it didn't meet our design standards, we wouldn't incorporate it until it did. Now, a lot of this was essentially stuff we had seen somewhat before test-driven development. You're taught from the very beginning at Moravian to use that, but we had to use it in new ways. Something not a lot of us had seen was conducting tests when you have a piece of software that is interacting with the external environment. It seemed sort of like a paradox to us. How do you test something that behaves unpredictably? And this is a good example of it. The Tanzo server, we make requests to it, and it returns us CSV files, usually. Sometimes, though, it doesn't work. How do we write a test then to make sure that our application behaves correctly when we get a connection error, say? And you do that using something called mocking. The idea is you create an object which takes the place of the thing that is going to vary, and you make it behave in a fixed manner. So for instance, we would mock out the Tanzo server and have an object that was set to behave to either throw a connection error or to return a file correctly. Then we could write tests that tested whether we responded correctly to that behavior. This is just a little snippet of code of a sort of a mocking type thing. We use a PyTest fixture here to make sure that an OS error will be thrown when yield is called. We create a mock session we call get, and then this will throw that error. And then this test ultimately is going to have to make sure that we respond correctly to an OS error being thrown. Now, again, a lot of this testing stuff was a major focus like mock, but even when we did it, we wanted to make sure that our code essentially stayed clean.
So Throughout the course, we studied through the series of clean code. Some of the things that we talked about throughout our studies was, with naming conventions, the name should have an intent, and you should really take the time to think about a good name. You shouldn't have to comment to tell the people what the name does, because if the name is good enough, it'll say it itself. With functions, it's what we do. It's the first tier of organization, and it's the first container that we put lines of code into. They should do one thing, they should do it well, and they should only do that. While dealing with arguments, the fewer the better. In regards to the structure of functions, the big public methods should be at the top, and private methods should be at the bottom. So as you read downward, the function lowers an abstraction. The technology we use in order to automatically verify all these conventions I mentioned in the Clean Code series was Pylon. Pylon is based on PEP 8, which is a style guide for Python coding standard. Pylon not only verifies PEP 8 compliance, but it also has many more features that help us with coding standards, such as indentations, line spacing, and naming conventions. Personally, I always have a hard time with the naming conventions of Python because throughout my time at Moravian, most of the courses I've taken have been Java-oriented, which uses a camel case convention instead of a snake case, which is what Python uses. So I was always getting my Pylon checks for changing my names to snake cases. But throughout time, I not only caught myself changing the name before, matching it to a snake case, but also thinking of a good name with a good intent. One feature of Pylon is that it allows you to customize the errors or conventions that are important to us. One thing that we had to do was communicate effectively with the team onto which checks we want Pylon to bypass and which checks we want them to make known to us. On the screen, inside the red circle, I have a couple of Pylon checks that we decided to disable. One being the missing doc strings. We took this out because we were trying to adhere to the Clean Code standards guideline for naming conventions in the sense that our names should have an intent, and ideally we shouldn't really need documentations for certain names if we're having good names for them. Another one being too few public methods. Pylon needs a certain amount of public methods for each module you create, but we wanted to make our modules small and contract for readability purposes. And we wanted someone who didn't really work on this code to not be overwhelmed by a large amount of content when it wasn't necessary at times. So that is an overall overview of how we did the process for our project. We really wanted to focus on the coding standard because it's very important when implementing new features. We didn't get a lot of time implementing certain features, and one of them being Docker.
So we want to leverage our microservices by running them in a Docker container, which is a container provider. We started on Dockerizing our project, but unfortunately ran out of some time. However, with the Docker version, what we gain is we get portability with our project to other machines, and we isolate our services and only expose what is needed for communication through networking. But like virtual environments, if we Dockerize, we remove the possibility of conflict running between multiple machines rather than running on a traditional server. Running on multiple machines and connecting through network, and we will also want to connect through network traffic through our Docker containers as well. Another tool that we hope to use to encapsulate our application was Faker.
So during our development process, we were all using our MacBooks, using Mac OS. But our production environment is a Linux server running Ubuntu. Fortunately, we ran our demo here and everything worked okay. But there was a risk of cross-platform dependency issues. To counter this, we wanted to use Vagrant to create an Ubuntu virtual machine on our local machines for testing purposes during the development process, to make sure that all of our code was being tested in the environment that it was eventually going to run on before we pushed it to the source, to the main GitHub account. This was another thing that we ran out of time on. We did actually learn how to create and provision instances of a vagrant, but it wasn't something that we ever got the chance to incorporate into our process in the way that we were hoping to. But like I said, fortunately it turned out all right despite not implementing Docker or Vagrant. A lot of this, a lot of the fact that it did work out so well was due to keeping to our clean code practices and our coding standard, and from some of the tools that we have in place to make sure that our code didn't deviate from that standard. The whole concept of clean code and test-driven development really shaped the direction of this project this semester. Having these tools and practices in place kept us on track, and it kept us from experiencing a lot of the slowdown we talked about at the very beginning of this that often comes later on in a project. This project caused a pretty significant shift in the way that I think about coding standards, code structure, and I'd wager I'm probably not alone in that in this room. So thank you for coming to hear about our project. As we open up for questions, I'm going to leave it on this slide, which shows all the technologies we mostly incorporated into our project, all the technologies we learned this semester. Thank you.
Questions?
So, as we all work on projects for classes, for outside projects, for whatever sort of situation we're working on projects, you get to a point in the project and you're towards the end of it, and then you realize that you could have started it better, could have started it with a different vision. What's one thing, and this is for anybody, what's one thing you wish you knew about your current stage of the project heading into it? One direction that you knew you were heading?
I guess for me at least would be the architecture. So with initially when we were starting with Docker, we wanted to create, since we wanted to Dockerize all of our microservices, what happened was, given our current structure, we had everything all under one package, which doing with Docker made it much more difficult and very convoluted. So if we would have known earlier that we were going to move towards in that direction, then I think I would hope to earlier to restructure ahead of time, so that way towards the end it's not as confusing, especially considering we have to go through and fixing all of our references and the files and so on. But luckily with our standards and how we were practicing clean code and with our process, like even doing that was not as bad as it could have been.
So, very well done and very, very cool story to follow. So let's say Whole Foods called you up and they want to inventory all the beer in the country at Whole Foods on Amazon. What would, out of all this, where do you think what do you think would happen in terms of the technologies you picked and
Well,
the architecture you chose?
I think the
That's
nice
not a
thing.
leading question.
I think the nice thing about we tried to keep our code in discrete pieces. The nice thing about that is that some of that functionality is pretty easy to take out and use in a different context. I imagine there are pieces of this project that could be part of something like that, but it's something that fortunately, because of the way that that we separated, that we kept those boundaries that we talked about earlier, we could with some difficulty, but more easily than certainly other projects we've worked on in our academic careers. We could separate those pieces and use them for something else.
I would agree. The way you built it and the microservices architecture and the way you independently yet collaboratively worked would actually scale. And I hope you sort of see that thread into, if you were to go to somewhere in your career that was big, you'll see people doing this way. Curriculum credit to Dr. Coleman, that their teams have built stuff like this way, because it can scale. The people can scale, the way you work can scale, and basically the modular architecture can scale.
You even tackled getting through a firewall, that's 9/10 of
Yeah.
the challenge.
So does Tensos know that you did this? So if I was like an evil beer competitor, I could scan their inventory to see what beer they don't have and like try to fill their gaps or see what they're selling and stuff.
Yeah, well, that's true, but that's, that.
Was there terms of use or anything floating around?
No.
I'm sure he's going to keep you out of jail. Wow. Should we record this?
Oh, yeah. So you mentioned that you had some pull request conflicts early on, and you had some Scrum adjustments that helped. Who acted as your product owner in that? Like, who would settle like any kind of debate or would have the final say if there was any kind of?
Was there any conflict?
Or was there any conflict? You guys
It
were
was
pretty.
kind of a mishmash. Sorry.
I was just going to say, I think a lot of those debates actually got handled pretty organically. I'm not sure if there ever was a point where two people were loggerheads and needed it to be a third party to adjudicate it.
Who was actually doing the approving of the pull request?
That would be whoever at the time would review the code itself. Like, say for example, if I looked at John's code and I had some things and Marty input some things, if one of us were to think that the code is good enough, we could merge it ourselves. And obviously all of us would agree upon. We also had a separate group messaging notifying each other of what changes were made and if they were appropriate or not. Sort of a unison agreement also at the same time.
Yeah, and we also, like, when working on pull requests, we try to, like, for example, let's say if Marty and I are working on a pull request, we would try not to review our own pull request because obviously we would have the most experience looking at it. So we would usually try to get somebody else who hasn't looked at our work yet to make that approval or to see, because if a variable name, for example, looks okay to us, but to someone else they don't understand what text is going on with our code, we want to have that discussion because we don't want to just, if we think it's okay, we don't want to just pass it through because we want the whole team to prove on that.
But in the beginning, it was Dr. Coleman that approved the program. So he felt ready to let us go on our own.
So did you have like any kind of production, meaning a place that people that were not you could use it? Were you like maintaining a production place that you were pushing to?
Well, the GitHub on our master branch is considered our production for this case. Everything that was going up we had to make sure that was good for production. So I would imagine that in the future, if this grew into a much bigger project, we'll probably abstract away and have a development branch specifically, but everything that was in master was ready to go.
So did you create any, did you create branches at all, or no?
Oh yeah, we did, but just
So
not
you
on
would-
the
right,
master
right.
branch.
So
On
you-
our own local
Oh,
repos.
okay, but you didn't create anything like, release one or, your own
No,
branches?
just
Did you guys end up doing the tagging we talked
did.
about?
Yes.
We implemented tagging. We were able to do a version 1.0 and then, which was the working structure, and then we made a new version, which was the restructuring, which didn't work with the Docker debate. We didn't have a lot of time. But we were able to create two different versions using tagging.
big do you think the team could have gotten, if, let's say you had to do it faster, or whatever, the semester was half as long, how big do you think you could have scaled the team the way you were working? How many more people could you add before it started?
I think because there was a lot of functionality that we would have liked to have done but couldn't do, and because we were building it in a modular fashion, I think we could have added a lot more people, another, I don't know, 5 or 6 or 7, I think, once we went on.
Yeah, that's true. We implemented the project in such small pieces that, most of the time we were focused on specific tasks, and the overall structure of the project was something that we'd come back and look at every once in a while to make sure we were on track. But I think we probably could have incorporated several more people comfortably.
I want to ask that one in the other metric, right? Because to me, my answer to that would be, well, not much faster because you didn't know any of this stuff at the beginning. So I'm going to ask a similar type of question. Now you know a lot of you know much about these technologies. If we just wiped all of your computers and the GitHub account and said, okay, now we know the product that we want, go. Could you do it faster? And if so, how much faster?
I feel in a sense that we could do it faster. How much faster, it depends on the measure, on how much we looked into. Because some of us might be expert in some of these technologies, but others might have overlooked it and might have just got the basic knowledge, but not the in-depth portion. So an example would be a few people work on fixtures specifically, so they might have much more knowledge of that and could work on that portion very quickly, whereas a few others possibly could look into it and maybe test it, but not really do much with it. Well, I would say definitely now knowing these different technologies and knowing what they could do, we can also even doing restructuring add a lot of the features that we didn't have put in now that we know what we're getting into and what these technologies could provide.
I guess I'd ask this question in a different way.
A third way.
A third way, because we're forming these teams, et cetera, right? And one thing that we would ask is, okay, so you've been a team for this long, you're a standing working team, right? Now we want to add just a new feature. I'm not saying start over, but so would you say, we'll call it your run rate is a lot faster because you've gelled already as a team, or do you think a new feature you kind of still be starting and going through all the same steps?
I think I would agree that it would be faster because we've gelled and, like you said, but pair programming was something huge for me this semester, being able to work with not necessarily coding and doing, but watching and understanding how other people code and working with different people in pair programming. I think that's huge for just the time consuming.
Yeah, it's also a lot of the things we talked about, like the coding standard and the unit testing and the continuous integration server, all that stuff. That was at the beginning of the project, that was a huge slowdown. Once we got those things implemented and kept them up, we were able to branch off in different directions a lot faster, certainly, than we were at the beginning of the project.
So how did you make sure you're all independently doing your parts? Was someone sort of organically coming out of the woodwork and being the one to say, wait a minute, guys, we need to build this by this date, and sort of roping you in, or at least herding the cats of work?
There was some of that. I think we worked pretty well together as a team. I feel like there were a lot of things that we surprised ourselves with. We felt like competent people. Surprisingly. At some point, there were definitely points where we reached where Dr. Coleman, said, okay, we need to focus on this task. I'm pulling you off of whatever you're working on now.
I think that was true for specific features of the project. a lot of the times, like, it would be a single person that would spearhead a feature, and then they would kind of move things along in that nature. But for overall, I think it was mostly Dr. Coleman.
Yeah, and as college seniors, we have also a lot of classes. So it's, a lot of times we would meet here in the lounge area or lab area, and, a lot of time would be like in between different types of, projects and other classes, and Dr. Coleman does like to use our time. And surprisingly for what we had, what we were able to do this semester with the time that we had is I think is incredible. I can only imagine what we could accomplish if we actually were working 40 hours a week compared to how many hours we put in.
Do you guys all know each other from like sort of the cadence of classes over the last 4 years?
No. Here and
Not
there.
specifically, yeah.
I met pretty much everyone except John and Marty this year.
Yeah.
All right, who figured out how to get out of the firewall?
Well, it's always funny because I remember, I think it was a summer or two ago, where I think it was actually when we first doing Jenkins on a different project, and we set up the trigger for on GitHub, and everything exactly what they said on the docs, everything, and we're wondering like, why the heck it's not working. We're sitting here like thinking like, why is it not working? So we spent a day or two on it, and like, you know what, let's just move on. We'll come back to it later, and then we realized that it was being blocked by our firewall, and so now like at least especially when working on server stuff, like my first thought is the port open? Am I able to get out? And so luckily with with that and Dr. Coleman's expertise, we're able to avoid a lot of that this semester compared to when we first realized a lot of stuff.
Yeah, a big thank you to the operations people of IT for just working with collaborating with us.
Yeah, they opened a space for us in the network itself so that we could work on, which also where our servers are also running on, and we were able to work alongside with them, keep it maintained, and also any sort of bugs or anything that was out there.
And now that we're sitting here, I think I actually talked to them about making the Capstone server be accessible. So we might not even need the ngrok in this thing. It's an interesting, we should try that at some point. It doesn't hurt
But in
anything,
your
but
future
just,
career, you will need it.
yeah.
Firewall.
People your friend.
Of course, you can't use that tool, but.
Any other questions?
I just have one. You mentioned that you built a database and then you used it. What did you use for that?
So the
Style DB.
the styles?
Or was it the other?
We have two databases.
Yeah,
Yeah,
so
yeah.
we're not actually using a database currently, we're just keeping it in flat files. We have, data from a couple different sources, but
So you're just keeping them in the CSV and
yeah.
or text file?
Yeah, just CSVs. There was a little bit of a lag as we were collecting the styles the actual styles from the brewery DB. We were just, we just had a CSV file with silly style names in there that we were using to test with. But
So what would you use? Let's say you had to go to multiple events. Let's say you were going to go to multiple companies and scrape their beer inventory.
We
What
actually.
database would you want to use?
We actually had this idea in the very beginning of the semester, before we took a look at clean code, that we would want to put in a server. We were thinking of using MySQL for a lot of that implementation. And then but after reading the concept of Uncle Bob about deferring decisions and such, and sort of moving, and we decided to move away a little bit from the server because it might be a little too much to handle, especially with all that's going on that we already have. We deferred that decision later on and decided not to work on that portion for the time being.
So that's the next feature.
Yeah, that would have been one of the next features after the Docker and Vagrant stuff.
I just looked, that's our pull request
Yeah.
that Steve, you created
Yeah.
February 19th.
Yeah.
All the way
Right?
back
We
in
started
the day.
thinking about moving it towards MySQL, and then we
that
said,
might
you
be
know
the
what?
first one.
We don't need to do this yet. It's
Right.
gonna work this
And
way.
if it's not that, you know,
Then
it's
we
not that big of a
designed it.
data set, so.
And
So
we never needed it.
you beelined it for your minimum viable product and then worry about it later.
Yeah.
Basically.
Well, thank you, everyone.